In section 2, we'll start to talk about graphs of an equation. Okay, and of course it says an ordered pair AB is said to satisfy an equation with variables x and y if when A is substituted for x and B is substituted for y in the equation, the resulting statement is true. Okay, we probably already knew that. The graph of an equation in two variables such as x and y is the set of all ordered pairs AB in the coordinate plane that satisfies the equation. So first of all, let's see if we can determine which of these points satisfies the equation that we're given. Okay, we're given equation x squared minus y squared equals 1. And so if I look at 1, 0, that means I'm plugging in what for x? 1, and for y we're plugging in 0. Okay, so x squared minus y squared, I want to know if it's equal to 1, 1 squared minus 0 squared. That works. Okay. All right, what about B, where we're looking at 0, negative 1? Okay, this time we're plugging in 0 for x and negative 1 for y. Okay, it looks like we end up with what? Well, negative 1 squared is positive 1, but we're subtracting, so we get negative 1. So this one does not satisfy. Okay, and then finally for C, we're looking at 2 square root 3. Okay, so I'm going to plug in for x 2 and for y square root of 3, and so we get 4 minus what? 3. That does equal 1, so it satisfies. Okay, so we found out that 1, 0 and 2 square root of 3 both satisfy our equation. Okay, satisfy means when we plug it in, it works. Okay. All right, we want to talk a little bit about graphing some equations. And here we're going to graph by plotting points. That's not the most sophisticated way, but we'll start there. And we've got some steps here to help us. We're going to make a table of solutions. We'll pick arbitrary but convenient values for x, and then we're going to solve for y. We're going to plot the solutions as ordered pairs, and then we'll connect the solutions in step 2 with a smooth curve. All right, so we're going to start by graphing y equals negative square root of 9 minus x squared. Okay, thinking about, since this is a square root, I might try to plug in values that will give me perfect squares. So some things we might choose could be, I'm going to start with 0. That works well. Let's see, does anything else work well? Not really. Let's see, what about 3? And then also I'm going to look at negative 3. Okay, I think those things will work pretty good. It'd be interesting to know what's going on. We might have to kind of estimate at 1 and negative 1. Okay, so if I plug in negative 3, we get what? 0. Okay, so we're going to plot a point at negative 3, 0. Okay, if I plug in negative 1, Okay, that's going to give me 9 minus 1, or negative square root of 8. And right offhand, I don't know exactly what that is. So I'll get my calculator to come up with the value. And I get, I'm sorry, I did something wrong. I get 2.82, or negative 2.82. Okay, so we get negative 1, comma, negative 2.82. Okay, if we plug in 0, we get just what? Negative 3, very good. So 0, negative 3. And then if I plug in 1, it's going to behave the same way as negative 1. So we'll get 1, negative 2.82. And then the same thing here. If I plug in 3, I'm going to get what? 3, 0. Okay? So we've got 5 points, and we're going to plot them and see what they look like. Oh boy. Okay, I hope you all can remember them. Negative 3, 0, 0. Okay, I got it. Negative 3, 0. Okay, we've got negative 3, 0. And then I think we also had 3, 0. And then we had 0, negative 3. Is that right? Okay, then we had 1. It was about negative 2.8. Is that what I said? And then negative 1 was also about negative 2.8. Okay? So that gives us a pretty good idea about what this might look like. That last step was to connect these solutions using a smooth curve. So it may look something like that. Okay, like I said, we'll talk about some more sophisticated ways to graph these equations, but for now, this is one way we can do it, just by plotting points and then going back and connecting the points. Okay, questions about that? All right, excellent. Okay, if we look at the other one, we've got y equals x squared minus 4 absolute value of x. Okay, so we might pick points starting at 0, kind of in the center, and we might look at 0, negative 1, negative 2, maybe negative 3. Then we'll do 1, 2, and 3. Okay, everybody pick a different value, so that we don't have to spend too much time calculating these, and see what you come up with, and then we'll plot these together. And I'll do just a few examples here. Okay. All right, I think I've got most of them. What'd you get for negative 3? Okay, negative 3. So we get negative 3, negative 3. Also 3, negative 3. Okay, and anybody for negative 2? Okay, -4. Okay. Something we'll talk about a little later is symmetry. And it looks like we have symmetry here. Okay. And for 1, I'm guessing you probably got -3. Is that right? Is that right? Okay. All right, very good. Okay, so if we plot these, I will not remember all of these. Okay, we've got -3, -3, -2, -4. Okay, -3, -3. Okay, then we had -1, -3. What just happened? Okay, -1, -3, 0, 0. What else? This should be +1, 3. Okay. 2, -4. Okay, pretty interesting. Looks like our curve might look something like that. Okay, questions about this? Okay, very good. We've already kind of talked about the idea of intercepts. When we talk about intercepts, they're basically where our graph crosses the x or the y axis. And no matter what type of function you're talking about, it can be linear, it can be a circle, it could be something like this that we're looking at. We find the x and y intercepts in the same way. It says an x-intercept is any point of the graph that crosses or intercepts the x-axis. Y-intercept is one that crosses or intercepts the y-axis. Even before we look at how we find x-intercepts, do you see? 2. Okay, we've got 2 x-intercepts. We've got one right here, and then the other one right there. Okay, these are our x-intercepts because this is where we are crossing the x-axis. How many y-intercepts? 1. Okay, it's right here. Okay, y-intercept. Very good. Okay, and so we mentioned anytime we're crossing this x-axis, the y-coordinate is going to be what? 0. Okay, so to get the x-intercepts, we let y equal 0, okay, and then we solve for x. All right. Anytime we're crossing the y-axis, then x has to be 0. So we'll let x equal 0. Okay. Strategies. That's what you need to think about as you study. Kind of like recipes, because the types of problems. Here's a major heading. Intercepts from a graph, so that's something I'm certainly going to ask you about on the test. And you need to mentally now have a strategy for dealing with that type of problem. Okay, so make those little mental notes, make those flashcards, and start thinking about how to deal with these things. Okay? Alright, so x-intercepts, we let y equal 0. Y-intercepts, we let x equal 0. And I want to emphasize here that both of these things are points. So points have how many coordinates? 2. Okay? We don't just say x equals some number, y equals some number. We have to have, if it's an x-intercept, it's going to be some number, comma, 0. If it's a y-intercept, it's going to be 0 and some number. Okay? All right, so keep that in mind. Notice that when the graph crosses the x-axis, I already said that, the y-coordinate is 0. And notice also when the graph crosses the y-axis, the x-coordinate is 0. Okay? Seems like we already talked about it. On the x-intercept, plug in y, or 0 for y, and solve for x. To find the y-intercept, plug in 0 for x, and solve for y. Looks like I skipped some pages. Let's see. Okay, so here we have a couple of examples. We want to find the x and y intercepts of the graph for the equation 3x minus 2y equals 6. We've already come up with a strategy for doing that. For the x-intercept, we set y equal to 0 and solve. Don't forget to write it as a point. And then same thing here for the y-intercept. We're going to let x equal 0 and solve. Okay. So for this first one, pretty simple. If I'm doing my x-intercept, we do 3x minus 2 times 0 equals 6. That gives us 3x equals 6. Or x equals what? 2. And so the x-intercept would be 2, 0. Very good. Y-intercept is usually the easier one to find, especially in more advanced equations. But for now, we'll plug in 0 for x. And so we get what? Y equals negative 3, and our point is 0, negative 3. That's our y-intercept. Okay. All right, what about this other one? What type of function is that? Okay, we could say polynomial. Also, we might say quadratic, right? We'll talk about different classes of functions throughout the course, and we should expect certain things depending on the type of function that we have. But for now, we'll just go ahead and plug in y equals 0 to find our x-intercept. So we get x equals 0 squared minus 5 times 0 plus 6. X equals 6. And so we get 6, 0 is our x-intercept. Now I'm going to plug in 0 for x. So we got 0 equals y squared minus 5y plus 6. What do I need to do to solve this function or this equation? Okay, we got a factor. How can we factor this one? Negative 6 and 1, okay. Y, is that going to work? If we do negative 6 and positive 1, that won't give us positive there. Negative 2 and negative 3, very good. Okay, y minus 2, y minus 3. Remember, hopefully from Math 102, the zero factor property. Since we have a product that's equal to 0, at least one of these factors has to be 0. That's why I'm going to say y minus 2 equals 0 or y minus 3 equals 0. Okay, and so we get y equals 2 or y equals 3. Okay, so this time we get two y-intercepts. 0, 2 or 0, 3. Those are my y-intercepts. Okay, questions about that? All right, take a minute and see if you can find the intercepts for this next one on your own. All right. You may have, depending on your factoring skills, gotten a little stuck finding the x-intercept, but at least we were able to come up with a strategy. Y equals 0, that's how we find the x-intercept, and then we need to solve this. So I'll come back and do that in just a second. To find the y-intercept, we let x equal 0. I plugged that in, and I was able to find that y had to equal -2. So my x-intercept, rather my y-intercept is 0, -2. Okay? Over here, to solve this, I need to be able to factor. Okay? If you don't know how to factor, it's going to be really important that we learn how. I'll go over a few things from time to time, but it's something you need to be working on consistently if you're struggling with that. Okay? It's not going to go away. Alright, so in this type of problem, since I can't just look at it like we did the other one, and I'll just back up to that one. Notice the problem right here. We had a leading coefficient of 1. So basically we were able to look at the factors of +6 that added up to -5. Okay? -2 times -3 gives us 6. -2 plus -3 gives us -5. Okay? However, with this problem, we don't have a leading coefficient of 1. We have this leading coefficient of 2. And so we're going to factor by grouping. The methods for that were we look at the leading coefficient of 2 and our constant, we multiply them together, and I'm going to get a -4. And this time I'm looking for the factors of -4 that add up to +3. And that would be what? -1 and 4. So what I'm going to do is rewrite this middle term using those coefficients. -1 plus 4 is 3. So I'm just writing 3x in a different way. And so we get 2x squared. And doesn't matter which one comes first. So I'm going to say minus x plus 4x minus 2. So this is that same 3x. Okay, and what we do from here is we group the first two terms and we group the second two terms. And we factor out the common factor from each one. So here, between 2x squared and x, what do they have in common? They have what? X. And so what am I left with? 2x minus 1. Okay, we have to have that 1 there to hold its place. Plus, we factor out a 2. And because that's what they have in common. And it's what? 2x minus 1. Very good. Okay. Now, we have two huge terms. Terms are generally separated by plus minus signs. Okay. Versus things that are factored are multiplied together. Here are my two large terms. And so I want to know if these two terms have anything in common. The 2x minus 1. Okay, and so what are we left with? X plus 2. And that's how it factors. Okay, and all of that's still equal to 0. So we say 2x minus 1 equals 0. Or x plus 2 equals 0. 2x equals 1. X equals 1/2. So I get 1/2 comma 0. Or x equals -2. So we get -2 comma 0. Alright, and so these are my 3 intercepts. 1, 2, and 3. Okay, questions about that? Alright, was that too much detail about factoring? Okay, good. Alright, make sure you go home and practice that in some other problems, alright? Because factoring comes up over and over and over again. Okay. Alrighty, moving on. Okay, symmetry. I thought we'd run into this pretty soon. Okay, one of the things we're interested in knowing about in our functions as we start to describe them is whether or not they are symmetric. Okay, symmetry means that one portion of the graph is a mirror image of another portion. The mirror line is called the axis of symmetry or line of symmetry. And so we have three types of symmetry that we need to think about. Three different types of symmetry. We can talk about an item being symmetric with respect to the y-axis. Also, we can talk about symmetry with respect to the x-axis and also with respect to the origin. Okay? All right, so these types of symmetry. When we talk about symmetric with respect to the y-axis, here's an illustration. And you can see that if I were to fold this graph on the y-axis, we'd have the mirror images. Okay? So in general, what does that mean for the coordinates? Well, notice here that minus x has a value of y and positive x has a value of y. So how do we summarize that, or how do we even test it? If I want to test for symmetry with respect to the y-axis, I'm going to replace x with negative x. If the equation is the same, then the graph is symmetric with respect to the y-axis. So here's our strategy. If we're talking about symmetry with respect to the y-axis, you want to know to replace x with negative x. All right? If we're talking about symmetry with respect to the x-axis, here's an illustration. Okay, that's what it looks like. And so even though I'm going out to this x value, it's possible for me to map to positive y or negative y. So the test this time is to replace y with negative y. Okay? And if the equation comes out to be the same, then we can say that it's symmetric with respect to the x-axis. All right? And then finally, symmetric with respect to the origin. It says for every point xy on the graph, the point minus x minus y is also on the graph. So we're swapping both the x and the y. So the strategy is to replace x with negative x and y with negative y. If the equation is the same, then we can say that the graph is symmetric with respect to the origin. Okay, so that's what we have to do, and we have to remember that that's what we have to do. Okay, so let's look at some examples. Oh, we got lots of examples. Okay, test each equation for symmetry with respect to the x-axis, the y-axis, and the origin. Okay. All right, so when it comes to symmetric to the x-axis, our strategy is what? Okay, replace the y's. Okay, replace y with negative y. Okay, so let's try that in a couple of these examples. If I do negative y equals x cubed minus x, okay, I want to solve this. Basically, in order for me to compare, I'm going to try to get an expression for just y so that I can compare the two. So in that case, what do I need to do here? Okay, divide by negative 1, multiply both sides by negative 1. That gives me y equals negative x cubed plus x. Okay, when I compare this to what we started with, is it the same? No, it's not. And so we say it's not symmetric with respect to WRT is fine, x-axis. Okay, it's not symmetric with respect to the x-axis. Okay? All right, what if I tried it in this other function? Y equals x squared minus 4 times the absolute value of x. Okay, again, I'm going to replace y with negative y. Okay, and so we get y equals negative x squared minus 4 times the absolute value of x. Okay, multiply both sides by negative 1. Okay, y equals negative x squared plus 4 times the absolute value of x. Are these two statements, is this the same as the original statement? No, it's not. Okay, so not symmetric. We'll just say no. Okay, very good. And I'll leave the other one for you to try in just a minute. All right, when we're talking about symmetric to the y-axis, our strategy is what? Okay, very good. All right. So when we come back over here to our first equation, we've got y equals negative x cubed minus x. Okay, so with this one, we've already got is y on the left side. We just need to reduce on the right. I'm sorry. It should be minus negative x is what I wanted to say. Okay, and so yes, that does become plus x. And then here, this is what? Negative x cubed. Right? Negative 1 times negative 1 times negative 1 leaves us with that negative. And so is that the same? No, it's not the same as the original equation. So still not symmetric with respect to the y-axis. Thank you. Okay, very good. And then the last concept is symmetry with respect to the origin. And our strategy is what? Okay. We have to do both. Okay, so we're still looking at y equals x cubed minus x. Okay, that's what we're starting with. So when I do my replacements, I've got negative y equals negative x cubed minus negative x. And I'm going to try to solve for y. Okay, reduced on the right side there, or simplified. And then when I multiply both sides by negative 1, I get y equals x cubed minus x, which is the same as what we started with. So we can say yes, it is symmetric with respect to the origin. Okay, questions about that? Okay, very good. I've left 5 boxes there for you. Why don't you test them to see if they're symmetric with respect to the various orientations. Okay, so if we're looking at the third equation, we're interested in symmetry with respect to the x-axis. So we get x equals negative y squared minus 4, or x equals y squared minus 4. So we say what? Yes. Okay, symmetric with respect to the x-axis. Questions about that one? positive. Right. When we raise a negative number to an even power, that makes it positive. If it's to an odd power, it remains negative. Okay. All right. With this one, now we're looking at symmetry with respect to the y-axis. So I'm going to replace x with negative x. And here we get y equals negative x squared minus 4 times the absolute value of negative x. So that's going to be x squared minus 4 times, well, just x, right? The absolute value of negative x is the same thing as the absolute value of x. And so this is the same thing that we started with. So we say symmetric with respect to the y-axis. Okay. And if we look at the next one, replacing x with negative x. And in this case, we don't really need to solve for y since our original equation is already solved for x. So I want to solve for x. X equals negative y squared plus 4. So we say what? No. Very good. All right. A couple more. Okay. This one with respect to the origin. So we had x squared minus 4 absolute value of x. If I replace both, negative y equals negative x squared minus 4 times the absolute value of negative x, or negative y equals x squared minus 4 absolute value of x. If I solve for y, okay, I get this, which is different from our original equation. So we say not symmetric with respect to the origin. Okay. And then finally, I think we had x equals y squared minus 4. If I replace both x and y, we've got negative x equals y squared minus 4, or x equals negative y squared plus 4. And when we compare, those are different. So we say not symmetric with respect to the origin. Okay, questions about this? How many people got all of these right? Okay, how many people got at least 3 of them right?